So what's chapter 7 about? So this material is not on, this material is on final exam part 2, right? And I mean, there are aspects of it which will help you with final exam part 1, but the entirety of what I'm doing today is not on final exam part 1, in the sense like, I think one thing I haven't asked you to do on a test, so what I'm trying to say is, what is on final exam part 1 is whatever has appeared in the tests and the quizzes up till now, right? If the concept, if the problem has not been in the test or quiz 1, 2, or 3, then it shouldn't be on final exam part 1, right? And one of the things that I don't think I've actually put on a test yet in here is like solving a quadratic equation that has a finding complex answers to quadratic equations, right? So let's talk about that. So chapter 7 is on quadratic functions and formulas and equations. So let's just explain what happens. So if f of x is equal to ax squared plus bx plus c, then f is a quadratic polynomial function, right? Or we usually just say quadratic function. Quadratic function. And there is a condition here with a what? A not equal to 0, right? And so I guess there are sort of 3 major things to think about. Number 1, how do you graph the function like this, right? Number 2, how do you solve the equation that corresponds to this function? Like, how do you solve the quadratic equation? And then number 3, like, what are applications? What are word problems that involve the use of this mathematics? All 3 of those things are addressed in chapter 7 of your text. So let's see here. So first of all, let me number 1 talk about how to graph. Actually, I guess I should start with how to solve, right? Because that's really the first thing. How to solve ax squared plus bx plus c equals to 0, right? So one way we can do it is just to factor a out, right? If we factor a out, we have a times x squared plus b over a times x plus c over a equals to 0, right? And then we can take half of this middle term and square that together with x added to x. And when we do that, we'll get back the x squared and the b over a times x, but we've also added in a b squared over 2a squared. So we have to subtract b squared over, 4a squared there. And let's see here. If I want to make those 2 fractions go together, what should I multiply the second one? I should multiply it by, like, 4a over 4a, right? And so in short, this gives us a times x plus b over 2a squared minus, parentheses, b squared minus 4ac over 2a quantity squared. Or I'll just write it as 4a squared. 4a squared, fine. Right? And so if that's equal to 0, what can we do? Well, we could use our imagination and rewrite this as the square root of whatever's there squared, right? Like, think about this. You can rewrite this as like the square root of that quantity squared, And if I do that, then I have difference of squares, right? I've got this squared minus that squared, which means I can factor. And what do I got? A times x plus b over 2a minus the square root of b squared minus 4ac over 2a times x plus b over 2a plus the square root of b squared minus 4ac over 2a. All of that's equal to 0. So how can these factors be 0, right? The only way the factors can be 0 is for either one or the other to be 0. And we can see from this formula that apparently x is equal to minus b plus or minus the square root of b squared minus 4ac over 2a, right? And so that, of course, is what? That is the rather famous quadratic formula, right? And I don't actually advocate using this formula for specific numerical examples because I think you'll actually have better success if you learn completing the square directly. All right? Now, so cases. Case number 1, b squared minus 4ac is greater than 0. Case number 2, b squared minus 4ac is equal to 0. Case number 3, b squared minus 4ac is less than 0. So the discriminant is b squared minus 4ac for the quadratic function, right? And we call it the discriminant because it discriminates what kind of solution you have, all right? And so in cases 1 and 2, we have real solutions, right? Case number 1's distinct real solutions. Case number 2, repeated real solution. In case number 3, though, that's the one I haven't asked you to solve in a test yet, I don't think. That's the case that we have complex solutions, right? That's the case that when I took that square root over there, I was taking the square root of a negative number, which means that the answer is actually a complex number. All right? So I can give you an example of each one. Here, let me pair each one of these cases with an example. So, for example, f of x equals x squared minus 5x plus 6, right? So this is equal to, x minus 2 times x minus 3, right? So in this case, we have, let me call this x over here, x plus minus, to try to distinguish it from the x, which is a variable here. So like here we have, x plus equals to 3 and x minus equals to 2 if you look at the quadratic equation, quadratic formula. What's the discriminant in this particular case? B squared minus 4ac is minus 5 quantity squared minus 4 times 1 times 6. So that's 25 minus 24, which is 1. Right? So my assertion that we're in case 1 is true. An example of case 2 would be something like f of x equals to 2x squared plus 4x plus 2, right? Because this is actually equal to 2 times x plus 1 squared. And in this case, the discriminant is 0. B squared minus 4ac would be equal to, 4 squared minus 4 times 2. A is 2 here, and C was 2. So we've got 16 minus 16, which is 0. Right? In the x plus and x minus, in this case, x plus equals x minus equals minus 1. All right? Those are the zeros of this quadratic function. And so finally, what's the third case? Is discriminant being negative? Well, there's lots of examples, but here's my favorite example, is probably this one. I guess it's f of x equal to, let's see here, x squared. I guess x squared plus 1 is a good example. All right, so in this case, to factor it, you actually need to look at that as like x squared minus I squared. So the factoring is involving the complex, the imaginary number I. So you get like x minus I, x plus I. In this case, x plus is equal to I, and x minus is equal to minus I. The discriminant in this case is what? B squared minus 4ac. What's b? What's b in this example? Can you guys tell me? Say again? You don't have your contacts on? Yeah, I haven't been able to find my glasses for like a few weeks now. It's driving me nuts. Now the one above, the coefficient of x was 4. That's why b was equal to 4 here. And this one, b was equal to minus 5 because it's the coefficient of x. What's the coefficient of x in this one? There is nothing there, right? So the coefficient is 0, right? B is equal to 0 for this one. So we've got 0 squared minus 4 times 1 times 1. In other words, 0 squared minus 4, which is minus 4, which is less than 0. Right? So if the discriminant is negative, that corresponds to the fact that the quadratic equation has no real solutions, right? But the quadratic equation always has some solution. It's just that it could be complex, and of course it could be repeated. Let me do one more example here, and then I'll turn the page to the next thing. Suppose we want to solve, 3x squared plus 4x minus 7 equal to 0. So what I would do here is I would factor the 3 out. Like that. And then I would say, okay, so that's 3. So then at that point, I can just drop the 3 outside, Like 3 times something is 0. That's just the same as the thing in parentheses being 0, right? So this I can trade for x plus 2/3 squared minus 4/9 minus, and 7/3. How many ninths is a third? A third is 3/9, right? So I could rewrite 7/3 as like 21/9. In other words, I got x plus 2/3 squared equals to 25/9. So if we complete the square and then we move the constant term to the other side, a quadratic equation can always be put back in the form something squared equals to a number. That number could either be positive, it could be 0, or it could be negative. If the number's negative, you're looking at a complex solution. If the number's 0, it's a repeated solution. If the number's positive, you're looking at distinct real solutions. And so like in this case, it's positive, right? So this says that x plus 2/3 is equal to plus or minus the square root of 25/9. Well, that's pretty cool because that's just plus or minus 5/3, right? Because the square root of 25 is 5 and the square root of 9 is 3. And so what we got is x equals to minus 2/3 plus or minus 5/3. What does that work out to? If we do plus, we got what? 5 minus 2, which is 3. 3 over 3 is 1, right? It's 1. Or the minus gives me what? Minus 2 minus 5 is what? Minus 7, right? Minus 7/3, nothing nice. It's just minus 7/3. And Brianna's like, I would have gotten that by slide and divide. No?
Well, yeah, I would have gotten that if I would have just slide and divide, but I'm trying to instead of going to multiple steps.
Of course, you could also do the quadratic formula here if you're more comfortable with that. I mean, every calculator pretty much that you guys are bringing to the test has a quadratic formula, a quadratic function solver built into it. You can check your answers, if you take the time to learn how your calculator does it. Like some of you have the Casio FX115, and that one's got like, I'm trying to remember, it's like an equation. You can solve quadratics by just putting in the values for A, B, and C. It will solve it for you. But that's only partially helpful because there are other questions that I can ask, which I really do want you to learn how to complete the square, right? If you don't know how to complete the square, there's certain problems you just can't quite solve. All right, so that's how to solve. We can either factor, we could use the quadratic formula, or we could complete the square. I mean, we have all these methods that we can use to solve the quadratic equation, right? So question number 2, how do we graph quadratic formulas, right? Like quadratic functions. Oh, man. Oh. It did look so clean before. Let me see if I can be right back a second. Yeah, well. It's closer. See if I can wipe the COVID off the board. Ooh. Yeah. See, but I think this is, well, anyway. It is what it is. It's something we've heard a lot more than we should this last year. Let's see here. Foolishly try to dry it with this shirt. Okay. So how to graph. I just want to point out to you that there are some things we should be aware of for graphing. Y equals to ax squared plus bx plus c, right? So number 1, if y is equal to a times x minus, and I guess I'm going to use r for root, like r plus and x minus r minus. So I'm using r plus and minus. Essentially, I've just changed notation, like x plus is r plus, x minus is r minus. I don't want to use x again. I want to use r plus and r minus to make you think of a number. They're specific given numbers. If this is the case, right, then if you multiply this out, what does it look like? A times x squared plus what? Well, minus r minus plus r plus times x plus r minus r plus. In other words, ax squared minus a times r minus plus r plus plus a times r minus r plus. So what I'm trying to tell you is that the constant term has to be equal to the leading coefficient times the product of the roots, right? The middle term has to be the leading coefficient times the sum of the roots with a minus, right? And yeah, I mean, that's somewhat helpful. Oftentimes A is equal to, many times A is equal to 1, right? So if A is equal to 1, easier, right? Because then the constant term is literally just the product of the roots, right? And the middle term, the coefficient of x, is just what? Minus the sum of the roots, right? So now, more than this, you should also notice that if we write y is equal to a times like x minus h squared plus k, that's another way we've looked at the quadratic, like this is the vertex form. So if I can write the equation like this tells me vertex is where? H comma k, right? And how does h relate to the roots? Well, if you go back to the completing square thing I just did and compare formulas, you should be able to see, in fact, that h is exactly root minus plus r minus plus r plus divided by 2. In other words, the vertex has to be found at the average of the zeros. If there are x-intercepts, it has to be like the average of the zeros. In fact, if the solution is complex, this is still true, because if you add the r plus and the r minus, the complex pieces cancel. I think you're still left with the same term. I'm not sure about that, but this definitely makes sense when r plus and r minus are real. What happens if r plus and r minus are equal? Then the place where the vertex is exactly where the root is, right? The vertex is actually on the x-axis. It bounces there. And k is complicated, right? To figure out the component, what k is in terms of the vertex, the parabola, my advice would be just to calculate k by, I would figure out what k is by looking at f of h. To me, that's the easiest way to do it. All right, let's look at some examples. All right, so in fact, I'll just continue with my examples that I already have here. Let's just graph them, right? Example 1, we've got what? X-intercepts of 2 and 3. So I guess I'll have to make it smaller. 1, 2, 3. And what's the y-intercept for this one? For example 1, y equals to x squared minus 5x plus 6. If we're going to graph that, what are we looking at here? Where does it cross? Does it cross the x-axis? What's it look like?
Is that the one that's like that? Or is it that?
Well, what does it mean to say that these are solving the equation f of x equals to 0, right? They're solving x squared minus,
Is it where it crosses the x-axis?
right? That's where y equals to 0. So y equals to 0 when x is 2 or 3. So that's like this point here and this point here, roughly speaking, on my graph. And what else do I know? I also know that 0, 6 is a point on the graph, right? Because it's got a 6 here, which is the y-intercept. So it seems to me that the graph looks, something like this, very crudely speaking. And
How do you know if it's positive or negative?
whether it,
Like for like the x-intercept?
because I had x minus 2 times x minus 3, so when, right, so when we set that equal to 0, we get it flips the sign. The factor, if there's a factor of x minus c, that means f of c is 0. That was our factor theorem.
And how did you get that third dot that was up there?
So this is 6, which is this guy. This is 2,
With those two there.
3. Now there is something else. I usually, when I'm asking for the graph of a quadratic, I'm trying to teach students how to graph quadratics, without a calculator, honestly, is what I'm after here. But you can use your calculator. But this vertex, right? Where is that? Now, we could complete the square, right? We could complete the square on that to figure out where it is. Or, if you'd like, you can use what I told you over here, which is that the x component to the vertex is at the average of the roots. Here the roots are 2 and 3, so the vertex is at 5/2. 2.5 is where the vertex is, And what's the y component of the vertex? It's complicated, like we have to figure it out. So what to put there? F of 2.5 should be the y component, right? Because this is the graph y equals f of x, where f of x is x squared minus 5x plus 6, right?
Where do you plug it into the
Yeah, plug it into the formula. So we've got 2.5 squared minus 5 times 2.5 plus 6, right? Now 2.5 squared, I think, is 6.25. And 5 times 2.5 is 12.5? I could be wrong about that. You should double check me on that one. I left my calculator in my office. Okay, and then we still have to add 6. So what are we looking at total here? 12.25 minus 12.5, which is what? Should we expect a negative number or a positive number here? Well, look at the graph. Yeah, negative from the graph. And we do get that because this is 12.25 minus 12.5. So the answer is minus 0.25. So there you go. That's how I figured out that this, the y component, y coordinate rather, of the vertex is minus 1/4, minus 0.25. And there you go. That's the graph. So we can carefully graph a quadratic if we know, like, what? X-intercepts, if we know the vertex, right? Now, there don't have to be x-intercepts, right? So we can't always, like, hang our hat on graphing x-intercepts because something like x squared plus 1 doesn't have any x-intercepts, right? So we can't really use x-intercepts to graph that, can we? But well, how could you graph y equals x squared plus 1 anyway? What would you do there? We could fall back on earlier work we did, right? Remember what we did? Like way back? Remember what we did at some point? At one point in this course, we talked about graphs of functions, right? And then we talked about creating new graphs from old. Did we not? Did we never do that in here? I talk about... not, maybe we don't do that in here. I'm trying to, so we never talk about like if you have y equals f of x, you add a number to it, it shifts the graph up 1 unit.
Like the rows of
Oh,
everything?
I'm sorry. Sometimes I just really want there to be things I've said in 113 in here, and I must. So okay, we don't know that. in like the next course up from here, you learn that if you take a formula that you like add a number to it, it just takes the graph that you already have, and just lifts the graph up by that value. So to graph x squared plus 1, I can just think about like y equals x squared, which is a known graph, and then just push it up 1 unit. It's kind of like the easiest way to think about graphing it. But, okay, we don't know that here. So how would I think about example 3? Well, so this one, we have no x-intercepts, right? Since x squared plus 1 equals to 0, gives me x squared is equal to minus 1, which tells me x is equal to plus or minus the square root of minus 1, which we denote by plus or minus I, right? So the solutions to the quadratic equation corresponding to this function are complex, right? There's no x-intercepts. What's the y-intercept? It's like right here, right? Y-intercept is 1, right? Let me call this thing f of x. Y-intercept is f of 0, which in this case is 1. So it's there. Where's the vertex? So let me just state for you. I should state for you this. I haven't stated this theorem clearly anywhere yet. So it's kind of buried in the discussion. Let me just state it as a theorem so you have it to use. Theorem: vertex of y equals to ax squared plus bx plus c is at minus b over 2a, comma, f of minus b over 2a. So, I mean, minus b over 2a is what h is equal to when you work through it. Like this h that appears in completing the square, that's exactly equal to minus b over 2a if you track the letters. And so for this problem, for my x squared plus 1, where's the vertex? What is b equal to here? I'll tell you, a is equal to 1, b is equal to what? C is equal, 0. Right, so where's the vertex at? The vertex is at 0, comma f of 0, but we already know f of 0 is what? It's 1, right? So this is a kind of funny example. In this case, the vertex is at the y-intercept. That can happen, right? It's happened here. And so what that means is that the graph looks like this. Right? And you can make the graph more detailed by plugging in more points, right? Like if you plug in plus or minus 1, you get 2 on the graph, right? This point or this point, say 1 and minus 1, how do I figure out what those are? So like 1 comma f of 1 would be another point on the graph. So that's 1 comma 1 squared plus 1, which is 1 comma 2. And also minus 1 comma f of 1. So these 2 points, if I could, carefully. Those are 2 more points on the graph, just to give you a little bit more sense of like what it looks like. And just as a general point of order, what if you want to make your graph better? If you want to make it more detailed, what can you do? Just plug in more points, right? So you can always like pick another point to evaluate the function at to add more detail to your graph if you want. And you guys are right. We haven't done too much of that in here, right? The lion's share of our focus in this course is on what? Is on solving inequalities, equations, and simplifying expressions, right? We did talk a little bit about functions in terms of domain and range, but that kind of thinking I was just doing is really more the province of like the next class, 113. All right, so anyway, have no fear. When I make your final exam, part 1, how will I make it? I'll tell you what I'm going to do. Make it easy.
Yeah,
1 plus 1 equals to 2. It's very hard to grade that. What's that? One question for your final exam, and what would that question be?
I think it was like how did I don't know, how did the slave move, something like that. But I don't have to read over.
How did the slaves move?
Probably like South America.
I was going to say probably walking,
Say the
but
Underground Railroad.
Underground Railroad. Yes.
One question, how much is it worth?
You know, when I was a kid, I always thought the Underground Railroad was the absolute coolest thing in the world. Like, it sounds amazing. Like, there's an Underground Railroad. It was in like the 1860s. Like, holy cow. 40s, 50s, somewhere in there. What's that?
And it's like, you know, when
Yeah, yeah.
he is from great Texas. No, I don't worry for it.
Example 2, you know, we've got y is equal to 2 times x plus 1 squared. So this one's easier. We don't need to think so hard. It bounces off the x-axis at -1, right? And so that means that the vertex is right there. So this thing just looks like this. And what's the y-intercept in this one? We can go back to the original formula, you know, and look for the constant coefficient, the constant term. The constant term tells you what the y-intercept is. It's at 2. Or 0, 2 if you want me to give you the label of the point. So there's the graph of that one. All right. So graphing, I say graphing a quadratic involves really a couple things. One is making use of the roots if you have them. If you have solutions to the quadratic equation, that's where the x-intercepts are, right? The vertex is the other thing we want to find, right? It's either at the average of the roots, if they exist. It's where the graph bounces off the x-axis, if that happened, if we're in the discriminant 0 case, or in the case that it's complex, well, in like case 3, then we kind of have to think through where is minus b over 2a, and that'll tell us where the vertex is, right? Anyway, yeah. Now, what are typical word problems? Can you guys tell me what would be a typical word problem that would involve quadratic? Can you tell me any? What's that? What's a typical word problem that might involve like a quadratic equation or? There are none. I like the way you guys argue. You're like, you're playing checkers, I'm playing chess. Very nice. So I guess it's up to me to make up the word problem then. Try to give you a chance to make an easy one. So generically speaking, the most common kind of like just problem is something like, here is some sort of formula that describes some physical process, right? Like basically here's a typical pattern. F of x equals to, x squared plus 4x plus 5 is number of dollars for producing X widgets. And then the question would be something like, what is the minimum profit dollars, possible? It's kind of like that, or it could be if you had a model where the coefficient was negative instead of, in all of my examples, the parabolas have been opening up, right? If the coefficient of x squared was negative, it opens down. I probably should do an example like that. Or same verbiage, same words, almost, but if I had like g of x is equal to, minus x squared minus 6x minus 13, what's max profit? Basically same words, but with max, okay? So the way to answer these is to figure out, think graphically, right? Basically the vertex for the graph is where the minimum or the maximum occurs, right? Think about it. So for the f of x equals to x squared plus 4x plus 5, if we rewrite that as x plus 2 squared plus 1, right? Then what's the smallest that formula can possibly be? 1, right? And that happens when? It happens when it's 1. I can't argue with that. What x value is needed to attain the output value of 1? For x equals to minus 2, right? So at this point, we have a problem, right? Whoever wrote this problem gave you an unreasonable problem statement. What does it mean to produce negative 2 widgets? Like what would your interpretation of a business of producing negative 2 widgets being? I mean, does that mean that? I mean, that must mean that somebody has to give them to them, right? I mean, they're not producing it. It must be it's given to them, So I would say that, like, you could argue that the problem doesn't make sense in a certain sense. But anyway, if x equals minus 2 widgets made sense, then the answer would be x equals minus 2. And the minimum profit is what? It's $1, right? Maybe this should be in, like, instead of dollars, it's actually in millions of dollars, right? The minimum profit's $1 million. Right? We can add units to make it more make sense. How about this next one, g of x? Well, I would factor the minus out, and that would give me x squared plus 6x plus 13. Then I would complete the square on that. That's x plus 3 squared plus 4. Right? So now that I did that little bit of algebra there, I bet Brianna can tell me what the maximum profit is possible. Oh, man. So my maximum profit, so this is less than or equal to minus 4, right? Because that could be 0, but generally speaking, it's going to be a positive number, and so this is going to be more negative than minus 4. So like minus 4 would be the max profit here. This is why you shouldn't just make up problems for classes, because you get all kinds of like crazy, nonsensical negative profit claims and such. Here, let me make a word problem up that will make more sense. Anyway, what I'm trying to tell you is if you have a problem where, like here's a quadratic formula, you can find the minimum or the maximum for the formula by finding where the vertex is for the corresponding graph. That's all I'm saying. And where is that? That's at, where is the vertex at? In terms of x, it's at minus b over 2a. So like I didn't really need to complete the square, you know? I could have just said, b is 4, so 4 over minus 2 is minus 2. This one's at minus 2. And here, b is, how did I get that? What's 13 minus 9 is, that's 4, yeah. What? Whoa, whoa. Oh, the maximum is at minus 4, but it happens at x equals to minus 3. I'm sorry, I was getting the x and the y as roll in my head intertwangled. Let me get rid of this. Listen, if you do the, my math lab from chapter 7, you'll be well prepared for the final exam part 2. So it should appear soon if it hasn't already. But if you email me to remind me to do that, and then I'll try to do it. It's supposed to automatically appear sometime pretty soon. What's that? Yeah, if you email me, that will make me remind me to do that. Now, that doesn't really matter. I mean, you don't have to do that before final exam part 1 again, because final exam part 1 is not chapter 7. Okay. Here's a typical question. There's a river, right? And you want to build a fence, and you got some cows, right? And suppose you got like, I don't know, 300 feet of fence. And your cows are it's a river of fire. All right, so like the cows are not going to go in it, right? Because cows generally don't like lava. So then the question is, like, how should you build a rectangular pen to maximize the area? Right? That's the question. So I'll draw a picture like that, right? Now we don't need to put fence on the fire side, right? Because the fire is going to keep the cows away. So we need these 3 sides, right? And it's a rectangle. So what do you want to label? I mean, we can label either the length or the width x. I feel like this one, I don't know, like whatever, this is x, right? If that's x, then I could call the other one y. And so we know a couple things, right? Like y plus x plus y equals to what? 300. Yeah, 300, because we're using 300 feet of fence. So I'll just say 300 and understand we're working in feet. And what's the area equal to? The area of the rectangular pen is, well, it's the length times the width, right? It's x times y in this context. But see what we can do is we can take that perimeter equation and we can substitute it into the area equation, right? Like this top one, what's this tell us y is equal to? $300 minus x divided by what? Divided by 2, right? Because this is 2y plus x equals to 300. So if we solve for y, we get 300 minus x over 2. So I can plug that into here, and that gives me the area as a function of x alone, namely x times 300 minus x all divided by 2. But what is that? That's a quadratic formula in x. Let me write it out again. This is actually minus 1/2 x squared plus 150 x. That's a formula for the area as a function of the width of the pen. Or the length. I forget which one was width and which one was length. You tell me. Anyway, it's the x in the label. So how do you maximize that area? You need to pick the x, which puts you at the vertex of the corresponding quadratic polynomial graph, right? Like you want to think about, if I had y equals to that, then y is biggest at the vertex of that parabola. Where's the vertex at, remember? So max, area max at vertex, which is given by x equals to minus b over 2a, right? What's b and what's a here? B is 150, and there's a minus from the formula. And what's my a? It's minus 1/2, right? So the 2 and the 1/2 cancels, and we're just left with 150 feet. So what are the dimensions of the fence which maximize the area? It's 150, basically it looks like this. You got 150 down here, and you put 75 feet here, and you put the other 75 feet over there. You can check me, y is equal to 300 minus 150 divided by 2, which is 150 divided by 2, which is 75. So that's how you build it to maximize the area. And see, we can solve that kind of problem because we understand that a parabolic quadratic function has its maximum or minimum at the vertex. That's the idea here. That's about the fanciest word problem you can come up with. I mean, there might be something about, like, I don't know, I think that's quite enough in terms of those. So I hope I've done enough so you know how to graph, know how to, at least can start attacking these. And and I'll try to post the homework sometime soon. In the time that remains here, let us look at the solution to test 3. And we will continue looking at the solutions to test 1, 2, and 3 next class, right? The whole class to review. And I know some of you have asked me for, actually maybe not one of you, but some of you are probably wanting to ask me, what score do I need to make on final exam part 1, in order to pass this class? Well, that is also dependent on what you've done for homework, right? But I'll try to put up something. I have an idea about what I can do. I might put up like a column in gradebook that has like grade needed on final for passing, something like that. For the final, I will allow you, for the final exam part 1, I will allow you 3 pages of notes. Final exam part 2 is going to be open book. So final exam part 2, it's much, much less restricted. Here's solution to test 3. All right, so let me see if I can improve the... Now, some of you did very well on this test, I think. I think you did better on this test than you have on some previous ones. So I think there's a few of you are going to keep this grade, I'm pretty sure. All right, see if I can make that a little bit bigger. All right, so problem number 1. What happened?
I'm sorry, I'm talking about history.
Oh, history?
Teachers.
Something interesting?
No, she's got the teacher that's only given her one question for
Uh-huh.
the final exam, and I'll have him next semester.
Ah, is that, you feel like that's a good thing or a bad thing?
Good thing.
It's a good thing.
Yeah, I'm trying to pass.
Yeah. I don't know, I have mixed feelings about history as a student. Like, it was okay, but it's kind of stressful.
That's how I feel about math sometimes.
Math is just fun. Biology, I never had biology. I don't know. It sucks. I hated chemistry,
I love chemistry.
mostly because I hate the labs, like the stupid goggles you have to wear all the time. I hate it. Hate it. All right, so the problem number 1 is, as simple as you can't divide by 0, so we must avoid x equals to 6, so that's the answer there. Example 2. I've seen people give me 8x to the 9. No! Do not do this. Like, the rule for exponents is not, when you have a quotient like that, you divide the exponents. Like, that is not how that works. It's 99 minus 11, so we should have 8x to the 88. This one down here, I think a lot of people got. We have to think through it. When you multiply x over x, we get 1 from this and a 1 from that, but we get 7x and 2x, well, minus 7x and 2x like that. I saw some people cancel, like they just canceled 1 over x and 1 over x and left me with minus 7/2. This is very wrong. Yes? I'm just stretching? All right. I'll allow it. I can't even begin to verbalize the diversity and wrongness I saw in this problem. I mean, you guys are great believers in diversity. Apparently, I saw it from this problem, but there were many, many different wrong answers here. But what you must do is carefully factor this one, carefully factor that one, and then look for common things that can be, reduced. So, like, there's an x plus 4 in here. There's an x plus 4 in there, and so those can be canceled. And then, of course, you've got x squared and x cubed, and this time x cubed wins, so we get 7 over 5x. In contrast, on the quiz, I had made it so that the x on top had a higher power than the x on the bottom, so you ended up with an x in the numerator for the corresponding quiz problem, right? So I was about to say something about the final in terms of how I will construct it. The way I will construct the final exam part 1 is to basically get out in front of me tests 1, 2, and 3, and then I'll probably ask my wife, like, pick a number